All right, good afternoon, everyone, and welcome to today's webinar for students and teachers interested in our 2020-2021 Student Video Challenge with the theme, Advancing Space Exploration Through Manufacturing. I'm Julia O'Brien, the Senior Director of Communications at the Association for Career and Technical Education, and I'm joined here today with Dr. Florence Gold, the Implementation Project Manager for NASA HUNCH. We at ACTE are so grateful to have this opportunity to partner with NASA HUNCH on this student video competition that's now in its third year running. While this meeting is meant to be informal in nature, we are very excited to bring to you today such a distinguished panel of experts. We're joined by Canadian astronaut Dr. Robert Thirsk. He will explain the importance of understanding medical issues that are faced by astronauts today and why that understanding is so vital to advancing space exploration. We have Larissa Hoffman. She's the Vice President of Edge Factor, and she will provide some video tips and storytelling tips to help you make both educational and inspirational videos. We are also joined by Chad Chamora. He's the Applications Engineer for Mastercam, and he will discuss the role of using cutting-edge software to design and fabricate flight hardware. We also have Allison Westover, the NASA HUNCH Culinary Project Manager, who will discuss the importance of understanding the packaging of foods for space and the unique nutritional requirements for the astronauts. And we have two additional panelists who have not yet arrived but should join us, will be joining us a little bit later on. And they are George Kessler, the NASA HUNCH Johnson Space Center team lead, who is here to explain how high school students are fabricating and documenting precision hardware that is currently being sent to the International Space Station. And finally, we have Nicole Brazil, who is the soft goods technician at Axiom Space, and she is also a past NASA HUNCH soft goods student. Nicole will talk about the manufacturing of sewn products used in space exploration. If you have questions while the presenters are speaking, please type them into the chat and we'll do our best to address them after each panelist speaks. And then we will have time at the end to address any additional questions you might have. And at that point, you can either type them into the chat or simply speak up. We would love to hear your voices. So let's get started by giving a warm virtual welcome to Dr. Thirsk.
Thank you very much, everyone. It's a real pleasure to be part of this webinar today. I'm no longer an active astronaut. I'm now a former astronaut, but I still remain engaged in the space program. I sense out there that there's a growing desire amongst spacefaring nations like the United States, Canada, Europe, Japan, to now travel beyond Earth orbit to a variety of interesting destinations in our solar system. So lunar orbit to the surface of the moon, asteroids, and in my mind, I think Mars is the ultimate destination. And I think that in 2 decades, we will see a crew of international astronauts who will land on and explore the red planet. The Mars mission is going to be daunting. It'll be unlike anything astronauts have ever previously flown. A flight to Mars, for example, will be a 50 million kilometer journey. And these distances, interplanetary distances, are so great that voice and data communication between mission control on Earth and the base on Mars will feature delays up to 20 minutes. So what this means is that if I'm at mission control on the ground and you're on Mars and I say, good morning, hello, how are you? It will take 20 minutes for you to hear that voice communication from me. And then another 20 minutes for me to hear you say good morning in response. So this means obviously that the ground support team at Mission Control will not have real-time control of the systems aboard the Mars spacecraft or on the Mars surface. And all spacecraft systems, and when I say spacecraft systems, I'm talking about life support, power supply, cooling, robotics, they're all going to need to be much more reliable systems than the ones we use today. And they must function by themselves, in other words, autonomously. With less oversight from the ground, astronauts are going to have to rely on their own training, their own capabilities, their own onboard resources to deal with emergency situations that will inevitably arise during the course of any mission. As you probably heard the deep space environment is hazardous to astronaut health. Zero gravity effects will result in deconditioning of the heart, the blood vessels, the bones, the muscles, and other physiological systems. And then living for 2.5 years in extreme isolation, Mars crews will experience psychological stressors such as loss of privacy and reduced comforts of living. Be aware that living aboard a spacecraft like the International Space Station or a Mars habitat is not like staying at a 5-star hotel. It's much more rustic than that. And the other thing the Mars astronauts will have to deal with is distant relations with their loved ones, family members, and friends as well. On top of that, beyond Earth's protective magnetosphere, the amount of ionizing radiation will be higher. Longer exposure to astronauts from galactic cosmic radiation could result in the formation of cataracts, could result in an impaired wound healing and even degenerative diseases. A large solar flare from the sun during a Mars mission could result in acute radiation sickness and even death. And many years after the mission is over, astronauts could experience genetic mutations and even the onset of cancer. In my opinion, it is the delivery of healthcare that is one of the most important obstacles that we need to overcome before heading off to Mars. Medical doctors and biomedical engineers are now rethinking how we can best deliver medical care. Ground-based medical teams have traditionally overseen the healthcare of astronauts in Earth orbit, such as aboard the International Space Station. And in deep space, this will no longer be possible, especially in emergency situations. For example, aborting a deep space mission to medically evacuate an ill or an injured crew member back to Earth will not be possible. Instead, future crews are going to have all of the capability to monitor and manage their own health. I think that at least one member of the Mars crew should be a broadly trained physician, but she or he will likely be supported by onboard artificial intelligence like R2-D2 or C-3PO to assist with health monitoring, diagnosis, and treatment. In other words, healthcare in deep space will have to become more autonomous and more intelligent. So if you are going to be one of those astronauts going to Mars, you will need to take your own supplies with you. Except it isn't just air, water, clothing, food, and spare parts that you've got to worry about. If someone gets sick, you will also need to bring the right medical equipment. But packing for every medical problem or illness is not going to be possible. Part of the solution will be to take 3D printers that can produce supplies on demand. The International Space Station already has a 3D printer on board, and NASA has been experimenting with it. So a Mars trip could include a 3D printer and raw materials rather than a large inventory of supplies that might not be needed, and that would take up unnecessary storage volume and mass. There's also a suggestion that future astronauts could bring along raw pharmaceutical ingredients instead of a full drugstore full of medications. So in order to manufacture their own medications on demand as required. So I'm aware that the NASA HUNCH Student Video Challenge for this year is advancing space exploration through manufacturing. I've always valued the involvement of students in the HUNCH and the ACTE programs. Again, since cargo resupply from Earth for a Mars mission will be impossible, I hope that some of you will consider how 3D printing of medical equipment and pharmaceuticals could be used to augment the onboard inventory of medical supplies and thereby help maintain the health, the well-being, and the performance of future Mars astronauts. So I'll wrap up by saying that while I have been dreaming of a travel to Mars since I was your age, an actual mission to the Red Planet is finally starting to feel like a possibility. This is exciting stuff. So in the future, we will depend on your ideas to protect astronauts and to make the exploration of deep space exploration possible. So thank you for your help and good luck with your HUNCH project.
Thank you so much, Dr. Thirst, for your wonderful remarks and insights on future missions and the needs of space exploration. Thank you. So next up, we have Larissa Hoffman.
Hey everyone, nice to meet you. I'm going to be sharing my screen for the few minutes that I have to connect with you. So I am the vice president of a company called Edge Factor. And here is our platform. You can see some of the different stories that we've told. We have traveled coast to coast and really around the world to tell stories of people who are pushing back the edge of what's possible. We have partnered with NASA HUNCH actually on a film that we created called Reach Beyond that told the story of a young woman who created a part that went to the International Space Station. And today I'm excited to share a couple of key things that I have learned. I have won many different awards for the different films that we've created. I myself am a producer. I often will sit in the director's chair as well, which is one of the most enjoyable things for me to do because I love engaging with the cast. I love connecting with people and being able to really draw out some of the key phrases or interview moments that really make a film. And so today I was thinking, of course, about what are some of the key things that I've learned that I can share with you. The first thing, and here are the 5 best practices that I wrote out on storytelling. You're welcome to, of course, screenshot this information as well. The first thing is find a story worth telling. Ask yourself, why do I want to tell this story and what is the call to action for my audience? When you think about telling a story, I encourage you always keep the purpose in the forefront so that you understand the why behind what you're creating. You can make a film or a video that is super beautiful, really, really cinematic, but unless your audience understands why they're watching what they're watching, you've missed the point. And so oftentimes I will even have the call to action listed out in front of me on top of, at the top of our pages as we storyboard and as we create our different films, and make sure that the call to action is being accomplished, so you understand why you're creating this video and you understand specifically what you want your audience to do after the video. Now, our films are really focused on documentary style. Of course, there are many different types of films out there. If you're thinking about a comedy, the goal could be just simply to make people laugh. If you're talking about something that's a thriller, the goal is to scare. But for documentaries, there are always different call to actions and really lessons that can be learned from the key audience, from the key cast members that are featured. The second thing is identify your audience and speak their language. So for us, our audience is typically students. So we obviously have many different fast cuts and we want to adopt the language of our audience. If your audience is an educator, you want to be able to speak to them directly as well. So really understand who's going to watch your video and why. Interviews. Don't let the first way that you ask a question be the only way that you ask that question. And by this, I mean, listen as a director. When you're in the director's chair and you're asking your key, let's say, cast member, your key character a question, it's okay to ask them the same question a couple different ways to get a different response. In fact, sometimes I will even ask a question in such a way that the person sparks a bit of an emotion behind it. And so think about a couple different ways that you can ask the same question to be able to get the response that you want, a passionate response, and then choose that clip, of course, for the end video. So I put here, ask the right questions and ask them a few different ways. Okay, this one is far more of a practical how-to. Yes, visuals matter, but let me tell you, audio matters more. If you have rustling or if your character is hard to hear, that is very difficult to fix in post-production. So make sure that your audio is really set to the right specs. And then the fifth one, it says, take your audience on a journey, create some suspense. Don't give everything away right in the beginning. Make sure that you storyboard, that you understand what your introduction is, how that intrigue, that hook initially in your video, and then take your audience on a bit of a journey and create some suspense so that they watch the entire video, that they don't stop a couple minutes in. And the last thing I learned, and this is probably one of the most important things, is that oftentimes, at least in my experience, the best directors are actually editors, because they can see and understand what it's like to piece together a video, and they can, when they're directing, actually see that timeline in their head. And so I directed several different stories, and then I learned how to edit. And everything changed when I learned how to edit, because suddenly I knew exactly what I was looking for in these different, in the different takes. One of the things that I also wanted just to highlight really quickly is that you can actually watch all of our films that we create completely for free. So you can head to edgefactor.com and you can actually create a free membership as a student, and you can watch all of our films, TV shows, and short stories completely for free. Thanks so much.
Thank you so much, Larissa. That was excellent information and great tips for our students. Thank you. All right, next up we have Chad Shimura.
All right, there we go. Hi, everybody. Glad to be here. Thank you for having me. Thanks for having me on this webinar. My name is Chad Shimura. I am an applications engineer at CNC Software. CNC Software is, of course, the company that makes Mastercam CAD/CAM software located in Tolland, Connecticut. So our software, Mastercam, is a CAD/CAM software, meaning it is a CAD software where we can create designs, basically take ideas from our head and put them into a model and create them in virtual reality, which helps us to design these really cool, complex systems and see how these systems will work, how they interact, make sure parts are going to fit together. And there's a lot of CAD softwares out there. There's SolidWorks and Autodesk and all these different CAD softwares for designing. And Mastercam is able to work with all these softwares. We can open their files, we can create models from scratch, or we can use a 3D laser scanner to reverse engineer actual parts. And then the CAM side is really where the rubber hits the road in terms of creating these parts for aerospace and space exploration. That's basically where we're going to take parts that were created from your brain into a CAD model and turn those parts into real tangible items. So in Mastercam, a programmer is able to model the part and then create strategies to turn a raw piece of material into some sort of an actual usable part. And so basically, to that note, Mastercam is essentially involved in all aspects of manufacturing. And manufacturing is an amazing industry that a lot of people don't really have a good appreciation for, just how much manufacturing touches your daily life. Everything needs to be manufactured. Everything you touch from day to day had to be made by some person or some machine. Some engineer had to design that. So basically, from the start of your day, with you're holding your toothbrush, your sunglasses, your steering wheel of your car, everything you touch had to be made or manufactured. And it's not necessarily a requirement that these items are metal and steel and aluminum and things that are, just machine parts. We want to actually see these, there's parts that are created inside of a plastic injection mold. So for example, talking about your daily routine in manufacturing, this is a mold for a bottle that a shampoo bottle that you're going to interface with every day. So there's the manufacturing industry is a really huge item that touches all aspects of your life. And at a certain level of that manufacturing industry, the very pinnacle of that is aerospace, right? All the best engineers, all the best programmers, all the best minds are going to gravitate towards the aerospace industry. So, making components for flight hardware, for airplanes, or for anything like that. The really high-end applications of manufacturing all gravitate towards aerospace. So Mastercam is a really big part of the aerospace industry. We have thousands of customers making millions of components every day for the aerospace industry and specifically the space exploration industry. Mastercam software has a lot of basically yearly updates where we always have the latest and greatest support for new machines, new technologies. You know, we can, if a new machine comes out the day after, Mastercam is going to be able to create programs for it to create these parts. So Mastercam is sold through a reseller network, and these resellers all support all of these customers who are creating these really cool space exploration parts. And as a corporate entity, CNC Software will provide assistance to all of our resellers who are giving support to the real world customers. And for example, we have this one part here that is talking about space exploration. This is a part that I'm working on currently. This is actually a real world item that's actually part of the docking system for the International Space Station. So this is an item produced by one of our actual Mastercam customers. And just to show that Mastercam as a software and as a company is able to support these people, we actually make these parts in-house. And we want to try to encourage our users to create these really cool parts and use the power of this really cool software to your advantage. So Mastercam as a company also supports the NASA HUNCH program in that we give free Mastercam software to schools that are involved in NASA HUNCH. So if you are involved in this NASA HUNCH program, hopefully you're able to leverage Mastercam and its really great network of users, of teachers, of just people in industry. Mastercam is the biggest CAD/CAM software in the world, and in that we are involved in aerospace and space exploration more than anybody. So I just like to encourage all of you to really, keep exercising your brains, keep designing, keep making, 3D printing and machining, all those all go back to the same core of manufacturing. We want to make these cool things and design these cool systems. And again, I'd like you guys to just keep at it, keep manufacturing, and keep coming up with really good ideas. So again, thank you all again for having me, and enjoy the rest of the webinar.
Thank you so much, Chad, for those excellent insights on manufacturing, and just really appreciate that excellent talk. Next up, we have Allison Westover.
Hello. I'm going to talk to you about a challenge that we have in the HUNCH program, and it is the culinary challenge. And the reason why it's a challenge is because we have certain nutritional requirements that we have to have for the crew to ensure that they have really good health while they're on space station, and also for future missions like to the moon and to Mars. So as part of this, whenever we are processing food, there's several different ways that we can process the food for flight. We have one method that is thermostabilization, and it's kind of like an MRE. I wish I had some of these to show you, but since we had to be at home right away with the COVID, I was not able to grab some of these from my office. But it's kind of like an MRE. It's like something that you would see like in the Army or any military service. And the food in that is basically irradiated so that it's taking away any kind of germs and things like that that could be left in there. And then you can heat up the food just like you could at home, but it's inside of this MRE bag. And then the crew can cut it open and then they can eat it. It has liquid usually with it. So you'd find things like a chicken noodle soup, or you'd find things like, like a fruit dish or something like that that has some of the gelatin aspect of it. And so whenever the crew cuts off the top of it, then it uses surface tension to stick to the fork. Another method that we use commonly is freeze drying food. Okay, and so what we're doing is we're taking out all of the liquid from it, and that way it'll stay longer. And so when the crew wants to eat it, let's say even if you're looking at, Cheerios with milk, it'll be freeze dried. And so the milk portion just looks kind of like white powder. And then when they get up into space, they can take that, and then they have two different methods. They have either warm water or cold water. So depending on what you want, then you can stick that item up to the warm water or to the cold water by a port that they have on this. And then from there, they can cut off the top again and they can eat it, and due to surface tension of the water that's added, then it'll stick to their fork or to their spoon. Another thing is we can vacuum seal things. So things like cookies and M&Ms and things like that that the crew might like to have. We just need to vacuum seal them. They're going to be in their same form that you'd find them in the grocery store, except we're trying to have it stay a longer period of time than you'd find it in the grocery store. So those are kind of the ways that we process food. Not all foods are really good for processing, such as part of this challenge, we had one team that made a wonderful beef Wellington. Okay. Around it. And the puff pastry is not something that can be processed and then reconstituted whenever they want to eat it. So it would just become mush. So we can't do that. So typically bread items are something that are really difficult for processing for spaceflight. So that's why a lot of times whenever you see the crew and they're eating something, they might be eating it inside of a tortilla. Because it's easy for us to send up tortillas, just vacuum sealed, and then they can use that. And we really don't want to have a whole lot of bread type items up there either, like not vacuum sealed bread and then open it up, because we don't want the crumbs to be floating around and getting into our ventilation system that we have on the International Space Station. Part of the reason why we have to be so stringent on our nutritional aspects for the crew is because their bodies change a lot in space. It is our space physiology. So things that happen to you on Earth change a lot whenever you get into space. So for example, one of the things that happens immediately upon getting into space is that you have a fluid shift, and you start to have more fluid that comes into your chest area, and you start to have a little bit of an enlarged heart, and your heart's having to pump harder. So the first few days that you're up there, you are literally just peeing off fluid so that you get to a new normal. Well, we know that if you eat a lot of salty foods, that you're going to start to retain fluid. And so we want to ensure that they have really good health. So we try to limit the amount of sodium that they have in our challenge, in our food that we're making for them. So we want to make sure that they don't have this extra fluid that's going to be causing some issues for them. Another big problem that they have is GI function. Their GI system just kind of slows down a lot because, you know, we actually use gravity a lot to help our GI system function. Throughout your GI system, there's all of these little valves that are basically helping your food to digest and to move along in the proper fashion. But whenever you're up in space, it wants to slow down. So we have to make sure that we have a lot of good dietary fiber for them so that we can help them with their digestion. We also, of course, have a specific kind of caloric content that we want depending on what kind of food they're eating. So if they're eating, you know, a normal entree, then we want them to have more calories. And the reason why we're so concerned about their calorie consumption is because they have a workout regimen every day where they have to work out at least 2 hours a day. And of course, they're burning a lot of calories. So we want to make sure that we are giving them enough proper whole nutrition through the food that we make for them. Sometimes we also have a nutritional, you know, we want to make sure that they don't have too much sugar. And of course, natural sugars are great, but we don't want to add more empty calories to them. We want to make sure that everything that they have is very healthy for them. It's also in our challenge, I have a lot of students that they'll work on having even more quality like supplementation. So maybe they're adding flax seeds for some of the omegas that they can have in it. Having other kinds of vitamins and minerals that can just help them and hopefully strengthen some of their immunity aspects for space flight. So that's really the reason why we have to worry about the nutritional content for our challenge, is because we want to make sure that the astronaut health is really good and that we're providing them something that will help them with their nutritional aspects. My challenge takes place over the course of a school year, and I have students from all over. Right now I have about 76 teams that are wanting to compete this year. We'll see how everything goes with our current situation, but they are very interested, and so in the fall we start looking at their recipes, myself and the Johnson Food Lab, because they are our partners in this, and we look at their items that they want to make, and we decide, is this a good recipe for food processing, and is it meeting all the nutritional guidelines? And then from there, we have preliminary challenges across the US, and we have different chefs and different people that are looking at tasting the food and seeing how it is. And then at the end of the year, we pick the top 10 teams. And from there, we have a final challenge in Houston. Management come, and we have the Johnson Food Lab there. And so we're all evaluating the food from that. Is also that they are learning a lot. So we have technical papers that are also due, and a video that is due to us, so that they can ensure that they're learning about food processing for spaceflight and why it's so important. So thank you very much for your time, and I hope that you've taken, that this has given you something to think about, and perhaps you might want to do your video in regard to space food.
Thank you so much, Allison, for that information on the culinary challenge and for all your insights on nutritional requirements in space and food production. It's really, really interesting. Great information. Next up, we have George Kessler.
Hello, good afternoon. My name is George Kessler, and I'm with the HUNCH program, and I have been involved in hardware manufacturing for most of my career out here at the Johnson Space Center, and so a lot of years of experience with manufacturing and assembling spaceflight items. So I'm going to piggyback a little bit on what Chad with Mastercam was talking about, and the importance of manufacturing, and in this case, manufacturing for aerospace and spaceflight hardware and what that involves. Starting with design of this type of hardware, these components, and these components and assemblies are designed to meet and stand up to specific requirements based on their application and what they'll be used for. In aerospace, these products are designed to meet stringent requirements to ensure that safety and performance. Some of them are structural and mechanical, thermal requirements, and corrosion resistance. And these requirements are critical related to the raw material selections for these items, so that they can stand up to the application that they're intended for. And the common materials used are aluminum alloys and stainless steels, and sometimes alloys like titanium and Inconel will be used for special applications. So like I said, some of these are structural components. Some of them could be flight control systems and payloads. And so these products require meticulous manufacturing techniques such as CNC machining, that's related to Mastercam, and precise measuring to tight tolerances, and also specialized assembly techniques when you get into the final assembly of these items to guarantee proper performance and to eliminate the potential for failures or reduce that potential. It also requires strict materials and process controls and documentation to be sure that things are manufactured and assembled to meet all of the requirements, or all of these requirements, in compliance with the drawings. And all of these steps in the process of every build are verified and documented to be completed properly. and to be sure that they were carried out in compliance with the drawing requirements, which really governs and makes sure that things are built properly and will stand up to their application. And material traceability is also a big deal in aerospace manufacturing. And material traceability is related to making sure that you use the proper material that the component was designed to be used with, and that you trace that material. And so that means you're going to track a lot number that could trace it back to where that raw material was manufactured, to the very mill where the base raw material was manufactured. So that traceability of raw material is critical to ensure these components will perform properly as designed. And so technicians and quality assurance people and machinists will have to track that material and keep control of that material to be sure that they know exactly what was used to build that component, and that material was the correct alloy and was properly controlled, so that it will produce a safe part that performs properly. And all of this helps reduce or eliminate the chances for failures that could cause a loss of life in aerospace, or loss of mission, which could be very expensive if you lose the mission. We definitely, the main safety guard is for loss of life. We do not want to lose astronauts. So that is why manufacturing and the manufacturing controls are so critical to aerospace and space flight, is so that we make sure we take care of our astronauts, and we take care of the program, and we take care of the vehicle, and we take care of the payloads aboard those vehicles. So manufacturing may seem simple on the surface, but there's a lot involved, and that's what we love to do. So appreciate your time, and it's good talking to you, and look forward to some questions at the end of the webinar.
Thank you so much, George. Excellent points on the importance of manufacturing. And I apologize to everyone. I have not kept up the questions in the chat box. So as soon as our last speaker goes, we'll address the questions. Sorry about that. Next up, we have Nicole Brazil.
Hi. Sorry about that. I'm in my car right now. I couldn't film inside at work. Hi, my name is Nicole Brazil. Can you all still see my camera?
We cannot. We can just see your name, but we can hear you.
Okay, I'll just speak then, because I have some notes here that I'm reading from, and I guess I can't show my face at the same time. So my name is Nicole Brazil. I'm the soft goods technician at Axiom Space. And soft goods plays a very important role in the aerospace industry. You know, it creates a level of comfort and protection for a number of things, one of them being an astronaut. A lot of people don't realize that a spacesuit is more than just metal and hardware. The very outer layer is a white material used to protect the hardware, and it also, you know, it creates a comfortable feeling. So there's not a lot of, you know, rigidness for the astronaut or anyone working around them. And another layer of the spacesuit is a bladder material that helps to hold pressure in the suit, and that is also considered a soft goods product, where a technician would have to fabricate it. Using, you know, use things such as sewing machines or heat sealing machines. There's a lot of different machines that soft good technicians encounter, and it's really actually quite exciting. There are also CTBs, which are cargo transfer bags. They come in all shapes and sizes and create different functions. Mostly they're to hold equipment or supplies that are being brought up to the ISS, and they're also meant to have a repurposed ability. For example, if you sent, you know, tools up in a CTB, they would also want the tool bag to open up and Velcro to the wall so that they could have both ends free and not have tools floating everywhere. So that's also a soft goods item. Astronauts also, they each have their own room on the ISS. It's called a crew quarter. And the lining of the walls is pretty much a blanket that helps add cushion. So if the astronauts in there relaxing and floating around, you can bump into the walls and it'll be soft. It won't be uncomfortable. And they also sleep in sleeping bags that attach to the walls. This is so they don't float around uncomfortably when they're sleeping. And you know, all materials have to be flight rated, meaning they meet certain requirements depending on its use, such as heat or radiation protection, or you know, durability, or the longevity of how long the material will last before it starts breaking down. That's all things that are taken into consideration. The most challenging part of my job is making sure tolerances are met. Sometimes there has to be very tight tolerances so things are safe and perform their functions properly. I've worked with a 32nd of an inch tolerance sometimes, or there could even be a plus or minus 0, which is really crazy to me. It's almost like, you know, there's no tolerance at all, but that's how strict it is for some things, especially going up to space. They want to make sure everything is perfect. You know, my favorite part of my job is meeting people who bring different ideas to the table and seeing those ideas come to life. And also, you know, the creative aspect. We want things to look aesthetically pleasing as well as functioning properly. Creating things that people see and are in awe of is just very rewarding, knowing that I was a part of the project. And yeah. So soft goods manufacturing is just as important as it is here on Earth. Not everything can be rigid or metal. We wear, you know, shirts, their material, the cloth in our cars, upholstery. It's pretty much the same concept. We don't want things to be uncomfortable and rigid. That's probably the biggest aspect that I think soft goods brings to the aerospace industry, is we add a comfortable protection to everything. Yeah, so I know it's really short. I'm kind of on a time crunch for work, but thanks for letting me speak. I'm happy to be involved in all this. So thanks, everyone.
Thank you so much, Nicole. I appreciate your time and just great information again. I'm going to go through the questions and then I'm going to turn it over to Flo. So I apologize again for missing those. We have, the first question is, do you, and any of our panelists are welcome to answer this, do you think growing medicinal plants would be a possibility for going into deep space?
I think, is that question for me?
I think it might. It might
Yes,
be.
it is.
Sorry.
Well, the answer is yes, with a capital Y. You know, one of the technologies that needs to be developed when we go to a deep space destination is the ability to do horticulture, to grow plants. And the reason for that is similar to what I mentioned earlier, that it's impossible to bring along all of the food, all of the water, all of the clothing, all of the spare parts, all of the experiments in a spacecraft on a 2.5-year missions. And that includes, we can't bring along all the processed food that we need as well. So we're gonna have to someday grow crops on Mars or on whatever destination surface that we go to. I think, Flo, that first of all, the first crops will likely be for food, for nutritional reasons. So perhaps things like tomatoes or strawberries or lettuce, something like that. And later, once we get some capability and some confidence, then yeah, we could think about growing some medicinal crops as well. But we have to take the baby step first before we get into medicines.
Awesome.
Thank you so much.
Thank you.
So the next question is for Allison, I believe. Can students still join the culinary challenge?
Hi, yes, students can still join the culinary challenge. We usually have teams between 4 to 5 people. Sometimes I've even had just one student be on a team, and they can go to hunchculinary.com altogether and find out more information, and it also has my email address on there.
Thank you, Allison. We have a question. I'm not sure who this is for. Does anyone know how much do the spacesuits weigh?
Spacesuits weigh about 280 pounds to 300 pounds, I think. But in space, you know, it's weightless because of that zero gravity going on there.
Sorry, and then we have another question. How do astronauts go about training for such extreme body changes in space while being here on Earth? And then secondly, are there a lot of robotics in use on the planned Mars mission to spare the astronauts from the rigors and dangers of the mission?
Yeah, I can take both of those. You know, the main thing that we do aboard the space station right now is exercise countermeasures. So we know that the body is going to decondition because of life in a weightless environment. And we can't stop it completely, but we can minimize the amount of deconditioning and help to make that return to Earth go a little bit better. So good examples of that would be the exercise machines that were briefly mentioned. We train on the ground to learn how to use the treadmill, the stationary bike, and also how to exercise properly with what we call the advanced resistive exercise device. Obviously, barbells and dumbbells do not work in a weightless environment, but we have a machine on board the space station called ARED, Advanced Resistive Exercise Device, which gives you the kind of exercise routine that you would do with dumbbells and with barbells at a conventional gym on Earth. So we train for proper technique and how to exercise on these devices in a weightless environment on Earth prior to flight. Robotics on Mars, absolutely. When you think about a Mars flight, think about a bigger and bigger role for automated systems and also for robots as well. When I was your age, one of my favorite movies was called 2001: A Space Odyssey. And the artificial intelligence entity in that movie was named HAL 9000. Now, HAL misbehaved during the movie. That's what the movie's all about. But HAL basically ran the entire spacecraft and even oversaw the healthcare of the astronauts, some of whom were in hibernation at the time. Aboard the International Space Station, we have a Canadian robot called Dexter that's aboard the station right now and is already playing an important role in minimizing the amount of EVAs or spacewalks that astronauts need to do, because Dexter is on the outside of the space station and can do a lot of the spacewalking tasks that in the past astronauts had to do. So this is really, really helpful, saves astronaut time, and even more important is a safety measure because it avoids astronauts having to risk their lives while going outside the space station when a robot can do that. So you will see more of this Dexter kind of robotic activity as we go further and further into the inner solar system. It's absolutely essential.
Thank you so much, Dr. Thirsk. I am going to turn this over now to Dr. Gold. We are about 5 minutes from ending, but I do want to give you time to ask any more questions, and I want to give Dr. Gold some time to speak as well about the challenge and offer any comments she might have.
Hi, everyone. I'm so glad to see all of you attending, and because I wasn't online, I actually was concentrating on the chat and trying to answer all your questions, which have been awesome, and everybody's presentation was super nice. And in reality, this webinar, Julia O'Brien and I thought, oh, students and teachers are using the online availability now, so why not have a webinar to help you decide on what aspect of advancing space exploration through manufacturing you would like to use. And we had Chad and George did an excellent job on telling you how important manufacturing is for space exploration and as for your daily life. So however, we didn't want to limit our video challenge to precision manufacturing, though I did want to concentrate on that because I feel that often gets neglected. But as Nicole told you, we do soft goods. And one of my questions was for Nicole, how important is soft goods? Well, it's really important for space exploration. The other thing is we have to produce food. And that's real important for advancing space exploration. And videos. Thank you, Larissa, so much for giving us those great tips. I love those tips. I took a picture of them because the video is now becoming more and more an important way of communication. And so even if you're not doing this video challenge, but maybe you're in the culinary challenge, you know, your video and your culinary challenge counts a lot. And when I video conference with students all the time in manufacturing, and it's so important that they can express their ideals to me so that I can understand what their issues are. Because no matter what kind of project you do for NASA HUNCH, there's always challenges and issues on it. So thanks for those tips. That will make our videos so much more interesting and valued to our viewers. Also, the introduction of the medical. Thank you so much, Dr. Astronaut Robert Thirst. He's actually been in some of our video challenges, and he did one on the vestibular system and that you can still go online and see at nasahunch.com. Go over to our YouTube channel. And he also did on the cardiac. So he's been a huge supporter of the video challenge throughout the years, and I really appreciate him coming on. I would like to give a virtual, and you can take off your mutes and give everybody a clap for the awesome work that
Thank you, everybody. Great presentation.
Thank you so much.
There we go.
Thank you.
Thank you.
We had 65 viewers, which is really good. Some of you asked if it's recorded, and it is recorded, and it will be on the ACT. We have to really give another hand of applause to ACTE because they manage all this. They are the most awesome partner that we have. So let's give another
We
hand.
feel the same way about NASA HUNCH and NASA.
Thank
so
you.
we're very excited to work with you. Thank you.
If I didn't answer some of your questions, we will answer them for you. I'm gonna, when this is over, because it's over right now, but I will stay online and answer those questions for you right now. But everybody else, if you don't have a burning question that's on the list, I'm so sorry that we didn't really get to discuss it, and you get to ask it live, but I thought your questions were awesome, and I'm going to answer every single one of them right now. But thank you all so much for joining, and my speakers. What a pleasure it is to see you all again. And thank you, thank you, thank you. So have a wonderful day and stay safe. Julia, do you want to say goodbye? Thank you, Larissa.
Thank you.
Thank you, everyone.
Thank you.
Thank you.
Bye. Thank you.
Thank you so much, everyone.
Thank you.
Thank you.
Bye-bye, thanks.
Thank
Okay,
you.
approximately, how long can you survive on a planet or in space without a spacesuit at the time? Well, my answer is, if you are outside that space station, you have to have your spacesuit on. A punctured hole in that space suit will make you in an emergency situation that you have to get right back into the space station. So that is a space station around the person. It's like they have their own little space station, and it has to be intact, not even a hole in it, or you will die. So that's a really important question. Do you bring a doctor on board just in case something goes wrong? So that was Dr. Thirst. He was an astronaut. He's been to flight several times, and he's the doctor aboard. And many times there have been a doctor aboard the International Space Station. There was another question from somebody that's asked earlier on if we had a man on Mars or Pluto. but the only place outside the United States that we have sent a man has been to the moon, and that was 50 years ago. Man has not visited any of these other planets yet. I like the comment, NASA's changing the world in a good way, of course. And that actually brings me up to another subject that we were nominated. We didn't get the award, but we were nominated for the Nobel Peace Prize. We didn't get it, someone else got it, but the International Space Station is truly an international collaboration between many nations, 15, and it continues as the mission to the moon is called Artemis, and we just had the announcement of the Artemis Accords, in which 7 other nations in the world have agreed to a peaceful, productive exploration of the moon and beyond. So we never go by ourselves. We always take humanity with us. And that is another important thing about manufacturing that I didn't talk about, in order to advance space exploration, we need to get our partners. We need to produce rules and regulations for everyone, and it needs to be an international process. So you could do a video on that.
I think that's everything, Flo.
I think that's it.
Yep.
And if anyone else has any questions, you could always contact Julia or myself, and we'd be happy to answer your questions. And thank you all for attending.